We're now ready to really get going on our equation review. This is the second section of the I can statement as I can solve one and two step equations with fractions and decimals. So go ahead and write equations right there and decimals right there. So remember, we're going to be solving these equations and we may have fractions as part of the problem, part of the answer. We may have decimals as part of the problem or part of the answer. So we want to keep that in mind, make sure we're writing things in the correct form. Remember, the only time you're going to write the answer as a decimal is if the problem's written with a decimal. So the warm-up questions, there's two of them here. What do inverse operations do to each other, and what does the word isolate mean? So remember, the word inverse means that we're going to be undoing the operations. So inverse operations undo each other. So let's write the word undo right here. And what does the word isolate mean? Isolate means get by itself. So when we isolate something, we get it by itself. So if you were isolated in a room, you'd be in the room by yourself. Now, a lot of math is learning how to do something and then learning how to undo it. It's kind of like being able to build a building, take it apart, take an engine apart, put it back together. Kind of these are inverse operations. They undo each other. And we use this idea when we're solving equations. And again, the goal of solving an equation is to get the variable all by itself on one side. So if we get it all by itself on one side, then we can read the answer to the equation off on the other side. And to do this, we use a couple of basic steps. So the first thing I've got here is, says step number one, we blank each side before we start solving. So this isn't really a solving step. What we're going to be doing here is we're going to be simplifying each side. So let's write simplify. We're going to simplify each side before we start solving. And what this does is it usually makes the problem a lot easier to solve. It's going to save us some time. We're going to avoid making mistakes. It's going to be a little bit more clear what we need to do in order to solve an equation if we simplify each side first. And then once we do start solving, the first thing we do is we isolate the variable term on one side. And then after we've isolated the variable term, we've figured out which side is going to have the variable on it. Then we isolate the variable. So let's write the word isolate here. So you'll notice that I'm saying the word isolate a lot. We do a lot of getting things by themselves using these inverse operations. And one thing I want you to note is I want you to note the difference between a variable term and a variable. The first thing we want to do is we want to isolate the variable term. So we want to get things like this. If it's got a variable with some other stuff with it, maybe a coefficient out front, maybe a square or something like that, we want to isolate that on one side. And then the last thing we want to do is we want to get the variable completely by itself. So when we're solving equations, it's going to be really important that we make sure that we show our work. We want to write our answers in correct form. And here we're going to round to the nearest hundredth if we need to. So we'll keep an eye out for those decimals. And before you reach for your calculator, I really want you to stop and think, could you do this faster? Could you do this quicker without using your calculator? You can always grab the calculator later on to double check and make sure that you got it right. So keep your eye out for some of these. I've got a few asterisks on these. Be thinking on here because I put some of these on here for a reason. So let's take a look at this one right here. So this is example A. You'll notice that we've got a two-step equation right here. This is the variable term. You notice that we can't combine these. They both don't have a y on them. And then we've got a 14 over there. So each side is already simplified. So let's go ahead and start solving this. We're going to get the variable term. So we're going to get this. And sometimes I have my students put a dotted circle around this. That's the variable term. We're going to isolate that. So I need to get rid of the adding 14. So what I'm going to do is I'm going to subtract 14 from both sides. You'll notice that those undo each other. On this side, the only thing left is the negative 3y, so we've isolated the variable term here. Now, there are some people that look at this and go, oh my gosh, I must have done something wrong because those cancel each other out. No problem here. 14 minus 14 is 0. 0 is a perfectly good number. So we're going to finish this off by now getting the variable by itself. We're going to divide both sides by negative 3. Those are going to cancel. That's going to turn into a 1. So these undo each other to make a 0. These undo each other to make a 1. And then over on this side, we have a 0. Remember, positive if you want to. Divided by a negative is still going to be positive. 0 doesn't really have a sign, so we don't have to worry about that one there. So that is the answer. 0 is a perfectly good answer. If we were to plug this in here, this would be negative 3 times 0. We'd get 0 plus 14. This side would be 14. The other side's 14, so it would indeed make the equation true. So let's take a look at this one here. Again, this side simplified, that side simplified. So we're going to go ahead and start solving. So I'm going to add 5. Now you'll notice that what I'm going to do here is I'm going to take a little bit of a shortcut. I'm moving this to the other side by changing the sign. I'm just going to cross that off because I know if I wrote a plus 5 right here, they'd undo each other. They're additive inverses. They'd make a 0. So the only thing left on this side is a 9a. I've isolated the variable term. And then on this side, I add these together and I get a 12. I'm now going to undo multiplying by 9 by dividing by 9. And again, if I'd like to, I can do this. I can just write divide by 9 and then I cross that one off from there. So a little bit of a time-saving thing here. So I get a on this side, and then I have 12 ninths. I do want to go ahead and simplify that. 3 goes in here 4 times, 3 goes in here 3 times. So that right there would be the simplified answer. Now, if you would like to grab a calculator to help you out with some of that arithmetic, that would be totally okay. But again, if you can handle this right here and just recognize, oh, 9 doesn't go in there evenly, so stop thinking of it as a division problem and think of it as a fraction, and then just go ahead and reduce that fraction. 3 is a common factor with each one of those. So let's take a look at this one. Again, good reminder here. This is a single step equation. The only thing that we need to do here is get rid of the 5/3 in front of the x. Remember, to get rid of a fraction in front of a variable, we're going to multiply by the reciprocal. We could think of it as dividing by 5/3, but remember, we never really divide by a fraction. So we're going to multiply by the reciprocal here, which means we're going to multiply by the reciprocal on this side. Again, notice that the 5's are going to cancel, the 3's are going to cancel, so I end up with x over here. And then I've got a negative times a positive, so the answer on this one's going to be negative. And notice I'm going to go ahead and put that over a 1. I can always make a whole number a fraction by putting it over a 1. And then I just multiply straight across. So I'm going to, whoops, I already have the negative there. So I'm going to get a negative 12 on the top, and I get a 5 on the bottom, and this is the answer right there. Again, please don't change that to decimal. Please don't change it to a mixed number. We're not going to write -2 2/5 or anything like that. We're just going to leave the answer like it is. Okay, let's slide down here and take a look at these guys right here. On this one, again, you'll notice that we've got this side simplified and that side simplified. I'm going to move the 10 to the other side by subtracting 10. Get rid of that. So we're going to subtract 10, cross those off there. So I end up with -18 over here, -13x over here. We're going to divide both sides by -13. I'm going to go ahead and write that on this one here so that you can see that those cancel off. I get x over here. Now, the only simplification that can be done on this one is a negative divided by a negative is a positive. So we're going to make this a positive. 18 and 13 don't have anything in common, so the answer on this one is just 18/13. And we just circle that. That's the answer. Again, we wouldn't change it to a decimal because the original problem doesn't have decimals in it. So we'll take a look at this one here. We do have some decimals on this one. You'll notice that we've got a variable term right here, and then we've got the -2. We're going to go ahead and move that to the other side. So I'm going to add 1.2 to both sides. I get -y here, and I get 5.4. And then on the other side, I get, let's see, that would be 4.9. Let's double check and make sure that I did that correctly. Yep, that's a 9. Don't have to carry anything. Okay, so we're in good shape there. And then on this one, think about this. You may have seen something like this before. We could just multiply both sides by 5.4. That would definitely undo the dividing by 5.4. So that would be an inverse operation. They would cancel off to be a 1. They are multiplicative inverses. But we'd be left with that -y there. So we can actually do 2 steps at once. We could multiply both sides by -5.4. So the 5.4 is going to cancel with the 5.4. Negative times a negative is going to be a positive. We end up with a y over here. And then I'm going to grab a calculator and throw that in there. So I'm going to go ahead and bring this up, and I'm going to shrink this down so we can see what's going on here. So let's go ahead, and I'm going to clear this off. I've got a 4.9 times a -5.4. Notice that negative, if I grab this one down here, I didn't use the minus. I would get an error if I did that. You can do this and we get -26.46. You could also just think, oh, that's a positive times a negative. The answer is going to be negative. And then you'd know that if you just put in 4.9 times 5.4, that would give the number part of the answer. So we're going to write down 26.46. We're going to circle that, call that one good. And then we're going to take a look at this one right here. Now, this is where things get a little bit interesting. You've solved problems like this before. You know that we have a fraction in the problem. I'm going to go ahead and make this bigger so we can see what's going on. But you may have seen that there is a way to deal with fractions in problems like this. So this is an equation, and here's the awesome thing. Because it's an equation, we don't have to deal with fractions if we don't want to. Now, if you've seen this before, awesome. If you haven't, This might take a little bit of getting used to, but it is kind of an awesome tool. You don't have to use it, but it is kind of nice. So what we're going to do is we're going to clear the fractions, and the way we clear the fractions, the way we get rid of the denominators, so again, if this is the ugly part. So if I just had a 2n and I had a -1 and a 1 on the other side, that would be totally okay. It's these denominators that really mess things up. That's what makes things look ugly and kind of nasty to work with. So what we're going to do is we're going to multiply all the terms on both sides by something that will cancel off all the denominators. So we need to cancel off a 3 and we need to cancel off a 6. So this is sometimes called the least common multiple or the lowest common multiple. So if you do like this method, you're welcome to use it. Make sure you use it correctly, and it's not always better or faster. The old school method works just fine. And remember, you can only do this if we've got an equation, because really we're taking advantage of the multiplication property of equality. So here's what we're going to do. I've got a 3 and I've got a 6 that I need to cancel off. Let's think. What is the smallest multiple of both of those? Well, a hint here, the smallest multiple of both of those has got to be at least as big as the biggest number. And it turns out that on this one, both of them are 6 is the smallest multiple of both of those. So if I were to do 3 and 6 and 9 and 12, list out those multiples, and 6 and 12 and 18 and so forth, you'll notice that 6 is in both lists. So that's what we call a least common multiple. So I'm going to multiply this side by 6, and I'm going to multiply this side by 6. So now watch what happens. When I multiply here, I get a 12n. When I multiply here, I have 6 over 1 times negative 1 over 3. So the 6 would cancel with a 3, and so we end up with a -2. And then on the other side, the 6's cancel, so we end up with a 1. Now here's the awesome part. In one step, we've gone from an equation with 2 fractions in it to an equation with no fractions whatsoever in it. So let's go ahead and finish solving this. So I'm going to go ahead and add 2. We've got a 12n equals a 3. We're going to divide by 12 on both sides. And then we're going to get n equals, and I can go ahead and reduce this. 3 goes in here once, 3 goes in here 4 times, so the answer on this one is 1/4. And that is the answer to the problem, but I am going to come up here and I'm going to erase this, and I'm going to change colors, and I'm going to do this a little bit differently. I'm going to do this kind of the old school way. So the old school way on this one would be this. I've got 2n minus 1/3 equals 1/6. So I'm going to move this over to the other side by adding 1/3. So I'd have 2n equals, this would be, let's see, this would be 2/6. Okay, so I've got 1/6 plus 2/6, that's going to be 3/6. And let's see, 3/6 is the same as 1/2. And then since there's a fraction in the problem, I'm going to think of everything as a fraction. So I'm going to multiply this side by 1/2, and I'm going to multiply this side by 1/2. So those 2's are going to cancel. And I get an n on this side, and I get a 1 on the top. 1 times 1 is 1, and I get 2 times 2 is 4. So that right there is the answer, and you'll notice that it's the same thing. Now, they both take up, in my view, about the same amount of space. There is something kind of cool about this, the fact that we had some fractions to begin with, we got rid of them, and then we got a fraction for the end answer. So that's kind of cool. So we call that clearing fractions. You don't have to do it if you don't want to, and you can only do it when you have fractions in an equation. That equal sign is a big deal here. What we're doing is we're multiplying both sides by the same thing. So we're using that kind of golden rule of algebra. Okay, so let's go back here and let's take a look at this one right here. One-step equation, look at this nastiness here. And this is another reason why you might hear people, and teachers in particular, say, hey, it's much easier to deal with fractions than it is with decimals, because if you'll take a look at these problems up here, the ones that had fractions in them, we can do these without using a calculator. This one we had to grab a calculator because I had decimals, and this one we're definitely going to use a calculator. I have to divide both sides by 19.37. So those are going to cancel off. I get x over here, bring up the calculator. Let's see, I'm going to make this smaller for the rest of this because I know we've got a couple we're going to have to use the calculator on. Let's see, so I've got, clear this off, 315.6, and we're going to divide that by 19.37. Again, double check, make sure I typed it in the calculator the right way. Hit enter, and we get this ugliness right here. Certainly wouldn't want to do that by hand. So let's see here, 2 decimal places, hundredths place. This isn't big enough to bump that up. If it was, we'd have to round that up from a 29 to a 30. So we're going to put it down 16.29. So 16.29, we'll go ahead and circle that. And then on this one here, let's see, well, this is a single step equation, already simplified here, already simplified here. We're going to multiply this side by 7/18, multiply by the reciprocal. So this is going to be 7/18. Those are going to cancel, so we get x over here. And let's see what happens on this one. Can we do any cross cancellation? Well, 2 goes in here once, and 2 goes in here 9 times. 7 goes in here once, and 7 goes in here 5 times. So what that would mean is our numerator would be 1 times 1, so that's going to be a 1, and the denominator is going to be 5 times 9, so that's going to be 45. All right, so I am going to pull the calculator up and double check this one just to make sure. I did 2/35 times 7/18. So let's throw in a fraction, so alpha y equals, so 2 on the top, 35 on the bottom. We're going to multiply that by alpha y equals, so it's going to be a fraction, 7 on the top, 18 on the bottom. And hopefully we didn't make any mistakes. And again, I'm using the calculator just to double check. And look, we got the right answer there, and we're all set to go. Now, this last one we can do without using a calculator. So I'm going to go ahead and go full screen on this one. And then we'll take a look at this last example. So this one right here, think of it this way. You've seen problems like this before, and we know that we just need to undo dividing by 4 to isolate the numerator there to get that y minus 3 by itself. But the other way you could think of it is think of this as clearing fractions. The denominator here is 4 and the denominator here is 1. So the least common multiple of the two of those, what I could do to clear that fraction is I could multiply both sides by 4. So the 4's are going to cancel. So I end up with a y minus 3 on this side. I've cleared the fraction from that side, and I end up with a 20 on this side. And then, of course, all we have to do is just add 3 to both sides, and we get y equals 23. All right, there is the answer on that one. And again, we've got a little self-assessment to do here, so kind of rate yourself on how you can do 1- and 2-step equations with fractions and decimals at this point. Got several practice problems. Make sure you ask for help if you need it. And we want to do one more thing. We know we've got the correct answer because when we plug it into the equation, it makes the equation blank. I'm hoping everybody knows the answer to this at this point. The whole point of solving an equation is to find a number or numbers that when you plug it in, it makes the equation true. That's what we're after here, is we want to make those true equations when we plug in the solution. All right, good luck on the assignment.